Hello friends, I hope everyone is doing extremely fine. So today we will be understanding what is DNS and how it works by writing a tiny DNS resolver in Go. So these are the sections we will be going over. First, we will start by understanding what is DNS and its purpose. Then we will look into lifecycle of a DNS resolver and how it works behind the scenes. And finally, we will be implementing our own DNS resolver in Go.
So now let's understand about DNS. So DNS stands for Domain Name System and it's used to translate domain names into IP addresses. Let's say you wanted to visit twitter.com, so you type twitter.com into your browser and hit enter. Your browser will immediately make a DNS query to your DNS server to know the IP address of twitter.com so that it can connect to it. Also, you can think of it like this. Imagine you want to call your friend but you don't have their phone number. So you will search their name in the phone book and can call them. In the same way, computer uses DNS to look up for the IP addresses using the domain names. That's why it is often referred as phone book of the internet. DNS is very important to us because it allows us to access websites using easy to remember domain names instead of remembering IP addresses. Now let's understand how DNS resolver finds the IP address of a website and have a look on its lifecycle. Also, just to mention, we are assuming that data is not cached in internal as well as external cache and a full DNS request will happen. And we will be taking our previous example of twitter.com and understand how DNS finds the IP address. So it's start by browser sending a request to DNS resolver asking about the IP address of Twitter. Now DNS resolver will start from the root and it will ask the root name server about the IP of Twitter. Root name server has information about all the top level domains like .com, .net, .org. As twitter.com comes under .com, it replies back with the address of .com name server. Now, DNS resolver asks .com name server for the IP address of Twitter. It replies back with the address of authoritative name server of Twitter. So, .com name server has information about all the domains coming under .com and it replies with twitter.com authoritative name server. So a authoritative name server is basically a server which maintains the original zone records and handle the zone queries, and these name server are hosted in the same zone where your website is hosted. So twitter.com authoritative name server is present in the same zone where the twitter.com website is hosted, so it can handle all the DNS query related to twitter.com, and it is very fast because it maintains the original zone records and the most recent DNS data. Now DNS resolver will make the request to twitter.com authoritative name server and it will respond back with the IP address of twitter.com. So this is the complete life cycle of a DNS query and how DNS resolver finds the IP address of a website. Okay, so now let's jump to the most fun part and see how we can implement our own DNS resolver. I have used Golang to build this tiny DNS resolver. Also, to keep this video short and bug free, I will not be live coding this but going over our implementation line by line. So before going over the implementation, let's see the dig command. It is very popular utility for doing DNS lookups. So let's do a DNS query using the dig command and see how our DNS response looks like, which will help us for more better understanding in the code. So let's do a DNS query to twitter.com. So as you can see here, this is how our DNS response looks like. We have 4 sections here, namely query, answer, authority and additional. These 4 sections will be used in the code to build our DNS resolver. So the query section contains the domain name for which we are querying the IP address. The answer section, which is not present here, it contains the IP address for the domain name which we are looking for. Then comes the authority section, which contains the name servers where we are redirected for the DNS query. So here we got 13 records for the authority section, all points to the .com name server. And then comes the additional section, which basically contains the IP address for the name servers which we have got. This makes DNS lookups very fast, because for the domain name which we have got, we instantly get the IP address from the additional section. Okay, so these are the 4 sections we are going to look in the code as well. Cool. So now let's understand about how our DNS resolver is implemented and how it's working. Also, just to call out here, you need to have little bit of Go knowledge to understand this. So the entry point of our DNS resolver is this main function, and here we basically have specified the root name server IP which we are using for our DNS queries. Then we parse the domain name from the command line arguments and check if it is not already appended with a dot. We basically add a dot to make the domain name absolute. And finally, we are invoking our resolve method with the domain name and root name server IP, and it will return us the IP address. So let's see how this resolve function is implemented. So if you take a look here, this resolve function takes domain name and root name server string as parameter, and then we basically parse that root name server IP string to net.ip class. And then if you see, this is the infinite for loop, which is basically making the DNS query and parsing the DNS response section. So this resolve function is responsible for binding all the things together, like making DNS query and parsing DNS response. So let's take a look on how this DNS query is being prepared. Okay, so this DNS query takes 2 arguments. One is the domain name and the other is the name server IP, and it basically prepares the DNS query object. So if you see here, we basically create the message object where we can set the question field, where we pass the domain name and the type A record which we are looking for. Then we basically initialize our DNS client, which will be responsible for making DNS request over UDP and passing our message object. So if you see here, we do client.exchange, which basically sends the request over UDP, and here we pass our DNS query object and pass the name server IP appended with the port 53, because DNS uses UDP as underlying protocol. Once the DNS request is sent and we get the response and error object back, we just reply with those 2 information. So if you go back to the resolve function, we get the reply and error object, and we first check if there is something, some error occurred. We just do a fatal log, and it will basically log and return with the exit with status code 1. If everything is good till here, we got our DNS response, then we will call the get answer function. So this is the first section which we are parsing. So let's take a look in this get answer function. It is responsible for parsing the answer section from the DNS response. So if you take a look here, we are iterating over the records present under the reply.answer, which is the answer section, and we are checking if we got a record. So basically we check that record header has the RR type, which means the resource record type, as type A record. If there is some record, we return the IP address of that. If we haven't got any answer, we just return null. So once this is done, this will return us the value, and we will check if it is not null, then basically okay, it's a happy case and we return the IP address of that. But suppose that answer section was not present and we didn't got the IP, so it will be null, and then we will call the get glue function. It will come to the else if, right? So let's take a look what this get glue function is all about. So get glue function is parsing the additional section from the DNS response. So if you take a look, this is pretty much similar with the get answer function. Here also we are iterating over the records present under the reply.extra, which is the additional section. So the additional section contains the IP addresses for the other name servers which we are being redirected to, right? So we will again check if we have some type A records present. So these glue records will be sent. So the IP address of the name server will be sent. And if there is no additional section or no records are present, then we just return null. So once this is called, we get back the name server IP value, NS IP value, and if it is not null, then we got the IP of a name server which we can make a TNS request to. So we just initialize NS IP value to the name server, and once again in the second run, when this for loop or basically this for loop runs, so this DNS query will be made to the original domain name, but the name server as the NS IP, right, which we got from this additional section. But if NS IP is also null, we haven't got any IP, then we call this get NS function. So if you have a look on this get NS function, so this is responsible for parsing the authority section from the DNS response. So if you take a look here, we are iterating over records present under reply.ns, and under the authority section we have domain names. So we will check if we have some domain name present. So we will check our resource record type as type ns, and if we got some domain name, we will return it, else we will return an empty string. So once this is called and we got the value of domain, we will check if it is not null or not empty. Basically we will call the resolve method again. So because we have got the domain, we need to resolve this domain into IP address. So we call the resolve method again with the domain name which we got from the authoritative section and the IP of the root name server which we have hard coded in the main function. So if you think of this resolve function, this is a recursive DNS resolver, right? Because we are calling the resolve function for the domain names which we get from the authoritative section as well. But in some cases, if there is some error like timeout error or some panic happened, so basically we will just break out from this infinite for loop and will return null, that we haven't got any IP. So once this resolve function is completed running, we will get the IP value, and first of all we will check if it is null, then we will print basically we are unable to find it, else we have found the IP address and we can successfully print it. So in short, these are the main functions or core functions you can say which is responsible for finding the IP address, which are the get answer, get glue and get ns. So these three sections are responsible for finding us the IP address, and this resolve function is binding it all together. It is making or it is invoking the DNS query and it is invoking all the other parser functions. Okay, yeah. Okay, so now let's run our DNS resolver and translate domain names into IP addresses. So I will go back to the terminal and run our DNS resolver, and we'll pass twitter.com as our first domain. So let me run this resolver. So as you can see, we got the IP address for twitter.com here, and if you see, it printed these logs which shows how our DNS resolver went to find this IP address. These are all the hops our DNS query went to. Also, if you see this dig command is printed, so basically I just logged this for debugging purposes. So if you see, I have added a print statement with dig here. So here I am here printing basically the dig command, so I can just use this command and run in the terminal. So if you see, basically to find the IP of twitter.com, it first made the request to the root name server passing twitter.com as the query. From there it got a glue record, which basically points to the this name server, and its IP is this. So we made a new DNS request to this IP asking about twitter.com IP address. So it replied with name server of name server address of this. So this is a authoritative name server which we have got. So now we've resolved this domain name into IP address. So we basically used our root name server to get the IP address for this domain. So in this step you can see, like, we got the IP address for the above name server address, and then we used this IP to get the address for the twitter.com. So we basically made a DNS request passing name server as this IP and asking about the twitter.com IP, and because it is in the same zone where twitter.com is hosted, so we got our twitter.com IP back. Now let's run for few more domain names. So let's find the IP for google.com. So this is it. It took it 3 hops, and let's do it for microsoft.com as well. So here is the IP address for microsoft.com. Let's do for netflix.com as well. So yeah, this is the IP address for netflix.com. So I hope you guys enjoyed this video, and please share this video with your friends, so basically everyone can learn DNS and see how we can implement our own DNS resolver in Go. This is it for this video. We'll see you in the next one. Bye bye.